Welcome back. This is an Aleks training video on drawing the reaction energy diagram of a catalyzed reaction. So I've given you the definition here of catalyst. A catalyst is a substance that changes the speed of a chemical reaction without itself undergoing a permanent chemical change in the process. So a catalyst is something that you would put with the reactants of a chemical reaction that are not actually used in the chemical reaction. So the catalyst is never broken down. You have exactly the same amount of catalyst at the beginning that you have at the end. It's not part of the reaction, but without it, it happens much, much slower. And what happens with a catalyst is it lowers the activation energy of the, making it easier to go from reactants to products. Okay, so let's see what they're asking you. You're sketching two reactions. One is without a catalyst and one is with a catalyst. And assume the uncatalyzed reaction is exothermic. Okay, so let's draw an exothermic reaction. And it doesn't matter what the reaction is. Okay, we're just going to be generic about it. Remember, energy, this is energy going this way. And you're going to have some reactants. So this is reactants. And if it's exothermic, that means the energy stored in the bonds of the reactants is higher than the energy stored in the bonds of the products. So this is products. Okay. Now, how do I get from reactants to products? I'm always going to have an activation energy. An activation energy is an energy that's required. Okay. This is the activation energy, E sub A. And if I can lower it, more reactant becomes product faster. Okay, think of this as popping corn, and I have the popper has very, very high sides or very low sides. So if I can lower the sides, the energy that popped corn has might jump over the lip of the pan. Okay, so if I have very high sides, very few popcorn kernels get out because they don't have enough energy to jump to the ceiling. But most have a lot of energy but don't have that much energy. But if I make the activation energy lower, the energy that those reactants have, some of them, more of them, will become products faster. And that's the whole idea. All right, so I'm now going to do, so this is uncatalyzed. Uncatalyzed. I think that's how you spell uncatalyzed. There's a Y and a Z in there. So catalyzed you still have the same. This is energy. Okay, I'm still going to have reactants. I'm still going to have products. Okay, but I'm going to have a smaller activation energy. Okay, so more of the reactants can become products easier. Okay, so do you buy a Lamborghini? Okay, if a Lamborghini costs 70 times a normal working man's salary, then the likelihood of you buying one is low. Okay, do you want a Chevy Nova? If it's, less than 1 year's salary for an average working man, you're more likely to buy it. It's that idea. You lower the activation energy, more reactants can become products. Okay? Pretty simple.